Wow, that's impressive. Thank you. So if you were able to attend this morning's keynote, you heard one of the great computer scientists of our times say, more or less, forget about Rx and machines are going to eat us. Now, I'm paraphrasing, and I tend to agree to a certain extent with the conclusions that he's come to, but I'm also really focused on the here and now, and I appreciate being able to pay my bills. And there are certain things that, as a developer, you need to know. And we can say that one of those things is certainly reactive extensions, and particularly today, we're going to talk about RxJava. So what is this? What do you think? Nailed it, right here in the front. It's a learning curve. And in fact, it's a steep learning curve. And whenever you start to learn about RxJava, that's the first thing people are going to say. RxJava has a really steep learning curve. And they're right. But if you're over here just getting started, why concern yourself so much with getting to this superstar level of RxJava, when instead you can gradually get better over time, taking some baby steps in that direction? And so that's what I really hope we can do today. I've spent a significant amount of time learning more and more about RxJava, and since I'm perhaps just a few baby steps ahead of you, I'd love for you to be able to do the same. In today's talk, we're going to focus on the 3 O's, or what we're going to call observables, observers, and operators. These are the basic things that you need to understand in order to be productive with RxJava. We're also going to talk about some of the most common operators, like map, flatMap, and filter. And then finally, throughout the course of the whole talk, I'm hoping that you'll have a better understanding of marble diagrams, which are used to express the intent of the various operators. So what is RxJava all about, really? It's all about programming with asynchronous data streams. Now, what do we mean by that, asynchronous data streams? Well, here are a few examples of that. So we could say things like click events, push notifications, database access, device sensor updates. All of these things can be considered asynchronous data streams because they happen at any particular time and somewhat outside of the normal flow of your program's execution. So let's look at just one example, like GPS updates. When a user is moving around, then you're going to get different values over time. So initially, you may have one particular lat-long coordinate, then they move, you get another value, and then perhaps with a slightly longer delay, you get another value. So this can be considered an asynchronous data stream. But let's look at another example, a server response. Now, this differs from what we saw with the GPS example because it's a one-time deal. So requests can be made to the server, and then the response appears. That's it. It happened at one point in time, but it's also a valid data stream. Let's look at another example. This time, we're going to take that same server response. We're going to get a request, but now you don't get anything back. You get an error. That's still a valid data stream. And so this brings me to our first pop quiz question. Which of the following is an asynchronous data stream? Would you say A, click events, B, database access, C, a server response, or D, all of the above? Right, it's D. You're really smart. Really, almost anything can be considered an asynchronous data stream, and that's the whole point. You can use RxJava in so many different scenarios, even if it was just one value like we saw with the server response or an error. But someone may be thinking, okay, why would I need to use RxJava when I already know how to deal with these things? I already know how to handle click events. I already know how to access my database. And here's the most important thing that I'm actually going to say today, and that's this. you don't have to. You do not have to use RxJava to handle those various situations. It's a tool like many other things, and it has its pros and cons. Therefore, I would encourage you to stick around, don't leave, because I'm going to show you some reasons when using RxJava may be really valuable to you. So, before we get into the specifics of what you may be interested in, I did some scientific research, and I'm going to let you in on it, okay? I'm an Android developer, so I took to Twitter, and I asked a bunch of Android developers, why do you use RxJava? And the responses came pouring in. It was actually really interesting. So people said making multiple API calls in parallel, the predictability of functional programming, being able to handle threads, and the list went on and on and on. So I took all of the responses that I received, and I grouped them into these different categories. So we have chaining, abstraction, data transformation, threading, composability, avoiding callbacks, and doing things in a non-blocking manner. Now, how is it that one library can do all of these things? Well, let's look at a few quick examples. So first, data transformation. This is some RxJava code. Don't obsess over it. We're going to cover it in detail later. What I want you to focus on is the portion here that says map. So this is an operator that RxJava provides to users in order to transform from one data type into another. So if we took this code, it will give us this particular output, which is a bunch of like old school winky emojis, okay? So we get that from this particular code. Let's look at another thing RxJava does, chaining. We took our same exact code, but this time we chained in a filter operator. This is going to impact the output of our RxJava stream. So instead now we're just going to get one row of winky emoji. Cool. Another thing RxJava does is it serves as an abstraction layer. And by that, I mean it helps you to focus on what you want done versus how you want it done. So if we take that code that we had before and we look behind the scenes, what's happening there, like with the filter operation. It's just some Java code. It runs in a style very familiar to us. We've seen it all before, but now we don't actually have to write it. So this is how RxJava can help us in being an abstraction layer. So on to our next question. RxJava is A, the silver bullet, B, simply magic, C, pure voodoo, or D, a library, right? I knew someone was going to say C. Yeah, it's D. It's just a library. Like many libraries you've learned to tame in the past, you can certainly conquer RxJava. It's also not the silver bullet. It has a lot of cons that come along with it. It's very complex. So yeah, it's just a tool. It comes with great responsibility. But if you're familiar with Kotlin at all, you might be thinking, hey, that RxJava code looks really similar to what I've seen in Kotlin collections. And yes, you'd be right, because Kotlin has this map operation to transform items. It also has a filter command to choose what gets returned based on some sort of criteria. But let's look at how Kotlin collections differ. So if we take this code here, we're starting out with our list of numbers 5, 6, and 7. Then the map is run on all of the elements, creating this intermediate collection. And the same thing is going to happen with the filter command. It's going to run on all of the elements, creating intermediate collection. So the key takeaway here is that we're having extra overhead by running these commands on our collections, and also they're taking place in a blocking synchronous manner. But RxJava observables are, for the most part, lazy. And so they don't have this extra overhead, and they also have the ability to execute in a non-blocking way. But of course, someone's going to say, I read the book, I know about Kotlin sequences. They can handle things in a lazy manner. And you'd be right. But let's look at how sequences work. So if we start out, we have our same list of items, 5, 6, and 7. But this time, notice the difference. We're going to run the map and then the filter on the one single element without creating any intermediate collection. And we'll do the same thing for the number 6, and once again for the number 7. We end up with the same output. But that brings us to this question again. So why use RxJava when there's Kotlin sequences? Well, remember what we said about RxJava. It was built to handle asynchronous data streams. So in the RxJava world, if we had this similar problem, there may be no data initially, and that is perfectly okay. Later, the number 5 shows up, and we run it through our pipeline. And the same thing, number 6. And maybe 2 minutes later, 7 comes in, and we do our work. This is the reason why people really enjoy working with RxJava, is that it can do things at any given time, and it doesn't have to be blocking. Another perk is it has a very flexible threading model. So we've talked about a little bit how it's all about asynchronous data streams. So it can allow you to choose the thread that you want to do your work on by using something called schedulers. So schedulers are really bossy, and they basically tell the observable, don't do your work here, do it there. Oh, by the way, don't listen for the answer here, listen to the answer over there. So that's how RxJava does that. So if we take our same code that we've seen already, the map, we can just drop in a subscribe on operator, and we can give it a scheduler that we're interested in, and then that's going to impact where this particular observable does its work. So there are lots of different schedulers available for you, and there are other ways to choose where you want to listen to the answer and how you want this to work. The key thing is that RxJava provides it for you without you having to obsess over any particular threading strategy or model. Okay. And this beautiful slide helps you to see that it also comes with many operators that are just not available in the Kotlin standard library. So if you want to do things based on a particular interval or some sort of time frame, or you need to combine observables in a very interesting way, this is where RxJava can shine over things that you can get by default in the Kotlin library. But now that we've kind of started to understand more of why people enjoy working with RxJava, it's important to know the basics. So we're going to focus on, first, the observable, then we're going to look at the observer, and finally, we're going to talk about operators, aka the 3 O's. So let's start first with the observable. You can think of an observable as producing some sort of stream of events. This can be anything that you're interested in knowing about. And it can happen in either a hot or a cold manner. So let's see what we mean by that. So first, hot observables start doing work as soon as they're created. They're not waiting for anyone else in order to decide, hey, let me get busy. So it's created, it goes, I have work I need to do, and it just gets busy. It starts just giving out hugs to everyone in any kind of direction that they decide. So those are hot observables. Now, what are some examples of hot observables? Maybe it could be a click event. You may have an observable. You have a very eager user. They could just be clicking away in your application, whether or not you are interested in getting those events or not. So now this differs from, here we go, code observables. They don't work unless someone shows up and says, hey, I'm interested in what you have going on. So it's created, and it's just like peacefully waiting. Just, I know how to do work. I just need someone to ask. Subscriber shows up, and it's like, sure, here you go, hugs for everybody. So that's the difference, hot versus cold. So what's an example of like a code observable? Perhaps accessing a file. Maybe you don't want to just get all the file's contents unless someone is actually interested in reading that information. So there's really very interesting ways to kind of think about how observables function. But where do we get these observables from? Like, where do they even come from? Well, they come from some factory methods on the various observable class. So here's an example of the create operator, and it takes a function that passes in its subscriber, and then it can handle all the interactions with the subscriber. So we're going to talk more about subscribers or observers shortly, but this is just like the most verbose way in order to create an observable. There are additional methods available, like just. In this example, you say, hey, I trust you. I just want you to give me these 3 things, item 1, item 2, and item 3. I don't need to be responsible for calling the methods on the subscriber. And then here's another example with the interval operator. This will create an observable that gives you numbers every 2 seconds. So just various options for creating and working with observables. So here I'm creating an observable using that create operator that we just saw on the last screen. Clicker, cool. And then I'm going to add in some log statements, and this is just a simple Kotlin class. It just prints out like, the main thread, whatever, the time, and it'll print the value that's inside of my statement. And then we're going to call the onNext method of the subscriber. So recall that this observable is responsible for integers. In fact, it's responsible for the numbers 5, 6, and 7. So that's why it's like back-to-back-to-back calls to the onNext method. And then finally, it needs to let the subscriber know, hey, that's it. I only wanted to give you 5, 6, and 7. Don't expect anything else from me. So it calls the onComplete method. Now, if we run this code, what you'll notice is that it doesn't actually print all of those things that we saw, except for done. Now, why is that? Right. So remember, we talked about hot versus cold observables. Well, this one is a cold observable. No one says, I'm interested in what you have to do right now. So it just doesn't print anything. Now, just to prove I'm not lying, this time I've added in a subscriber. And if we run the test again, we're going to get, the full output that we expected. There we go. Good. So, time for a quiz. Observables can A, emit items, B, be cold, C, be hot, or D, all of the above. Yeah, it's D. I want you to feel smart, okay? I'm doing this for you, all right? Okay, great, yes. Observables can do all of these things, and that's why it's a key aspect of programming with RxJava. So this time, we're going to move on to talk about the observer. And the observer is the abstraction that RxJava uses for listening to, or as the name implies, observing the various items or events that the observable is producing. So in its most complex form, it's this type of interface here. And I'm going to go through it. Sorry, there's more people over here. I'll be back. Okay. So the observer takes in a type T. And this is how it's saying, this is the particular item that I'm going to be responsible for. Next, it has this method onError. So it's one thing you'll hear people say often about RxJava. RxJava treats errors like a first-class citizen. So this is how it does it. It has this method. It receives a throwable if anything goes wrong. Next, we have onComplete. We talked about this a little bit before. This is how we say we're done. There's nothing else. onNext takes a T of type T. This is the thing I'm actually interested in. So if I want to observe users, this is where I get a user. If I want to observe smiley faces, this is where I'd get a smiley face. And finally, onSubscribe, which receives a disposable. So this is how we can say, like, I'm busy. I can't keep listening to all your events, however you want to think about it. So an observer also has a life cycle. and the order of those methods need to be respected. So whenever it is subscribed, it has to have a call to the onSubscribe method. And then during the normal flow of its life cycle, there can be 0, 1, or many calls to its onNext method. And then finally, it can have a call to onComplete if it's successful, or it can have a call to onError in the case of some particular type of failure. So here's an example implementation of that interface, and we're just overriding all the methods and logging whatever we get back. So if we connect it to our observable and then we run it, notice what happens. Okay, so you see all of that information, it goes through and it calls all of the methods, and we get the various results that we were hoping for. But sometimes observers just don't really care about all those other things. And for this reason, there's an interface called Consumer that RxJava has made available. And it has one method, accept, which you can more or less think of as the onNext call of the whole observer interface. And so here's an implementation of it where we just override its method, and I even left the signature of the print line to onNext, so we can see that they're basically synonymous. So if we run this code connected to our observable, then we're going to get the output that we're interested in, which is pretty cool. But if you look closely, you'll see that the IDE is giving us this gray squiggly line. So it's letting us know, hey, something's up with this syntax here. And essentially, we can convert this to a lambda. So if we go and we convert our consumer to a lambda, we end up with something like this. But we're not using this variable anywhere else, so we can go ahead and just jam it into the subscribe method. But once you see some Kotlin code like this, you're going to get another error, because it's like, hey, I already know, I really don't need you to add this extra constructor. So you can just take it out. You're getting closer. But now you have a lambda as the last parameter in a method. Kotlin says, get rid of those parentheses. Okay, we're getting closer. This time, we can go ahead and drop that declaration of the lambda in the arrow, because Kotlin knows, hey, there's just this one parameter in the lambda. I already know its type. It's not necessary, so I'm just going to use it. IT. And this is what you'll see most often when you're looking at RxJava code in Kotlin. So if we plop it in, run it, we're going to get the same exact result before. Okay? Now, pop quiz. Observers have a life cycle, always complete, never error, or all of the above. What would you say? Right, it's A. Not that nice. Wasn't going to all be D. Right? They have a life cycle. So they go through that little process that we saw before in the diagram, and they can either complete successfully or end in onError. So now we're ready to talk about the operators. And the operators are what help you to transform, combine, and as we saw earlier, create observables. So let's look at an example. And we're going to take our friend, the map operator that we've seen a few times already. It takes in a function that knows how to go from one type of item to another. So for instance, if we want to convert frowns into smiley faces, we could use the map operator to do that for us. So anytime a frown shows up, we're going to get a smiley face on the other end. And it'll happen throughout the life cycle of the source observable. But we've seen this example before where we had those numbers 5, 6, and 7, and then we used our map operator in order to convert the numbers, and it gave us all those winky emojis. Well, sometimes if you're not very familiar with the Lambda syntax, it can obscure what's really happening behind the scenes. And in those cases, it's really useful to see this whole thing expanded out to better understand what is taking place with your map operator. So this is what it looks like, and we're going to start here at the top. First, we're just going to create an anonymous class of type function that knows about integers and strings. It has one method, apply, which we override, and the apply method knows how to take in an integer and give back a string. And inside the method body is the exact same thing that we saw inside the lambda. It takes that one string, which is the winky emoji, and then it repeats it the same number of times that correspond to the integer that it receives. So just to put it like even more clearly, these two things are the same. So one, obviously extremely more concise than the other. And anytime you're working with RxJava and Kotlin or Java 8, etc., it's really helpful to break it out sometimes into the expanded version so you can better wrap your head around what the particular operator is doing. Okay, so what's the output of this particular code? We're taking an observable of just the numbers 1, 2, and 3. We're using the map operator to double it, and then we're going to print it out. Here are your options: A, B, C, or D. Right, it's C, okay? So 1 doubled is 2, 2 doubled is 4, and 3 doubled is 6. My math skills are amazing, right? You're impressed, okay? So we got it together, right? We're starting to really wrap our heads around RxJava. Let's look at one more. We're going to take that same code, but this time we're going to add the filter, and we're going to reject things that are not less than 6. Okay, is it A, B, C, or D? Right? It's going to be B, because the last number, 6, right, is obviously not less than 6. So hopefully you're starting to feel really comfortable with this like very basic RxJava. But now here's an operator that you're going to come across a lot when you start working with RxJava, and that's flatMap. And this is its marble diagram, and it gives us some insight into how flatMap works. At first glance, it may seem very similar to the map operator, but it differs in a few key ways. So first, flatMap's job is to transform an item into an observable of potentially a different item. Okay, so that's what its transform function does. So let's look at this in action. So here's our RxJava code. We're all about positivity. So whenever we're getting a frown, we're going to just flat map that to an observable of some down arrows. Okay? So if we start out with our two observables, the source and what's going to be our result, once that subscription is triggered, it's going to get busy emitting new items, and we're going to get the first frown. flatMap is going to jump in, create an observable of the down arrow, subscribe to it, and then emit it in a single. And the same thing is going to happen the next time we get another frown. Create an observable, and emit it. What's interesting is the subscriber has no idea that all of this is going on. All they know is, I have two down arrows that I need to pay attention to. And so why would this be really cool and super important? Well, because now when you're using flatMap, you can do long-running asynchronous operations without blocking the main thread. So let's look at an example. Say you have an observable of users, but you're actually interested in all of the blog posts that they write. You can now use flatMap to say, hey, for every single user, go off, give me all of their blog posts, and then I'll subscribe to it and just print them out. And you can think of many other applications of working with flatMap in order to do these type of things. So flatMap is super powerful, and there are many other operators just like it whenever you're working with RxJava. So someone's going to say, hey, Annyce, what about flowables and maybes and singles and disposables and all these other things? Literally, the list can go on and on and on. Remember, this is RxJava in baby steps. And I want to save something for V2 of this talk. So should you use RxJava, right? That's the big question. Well, think about these things. Do you like functional programming? Do you need to process items asynchronously? Do you want to compose data in some very interesting, elaborate ways? Do you need your errors to be first-class citizens? If you can answer yes to most, if not all of these questions, then I say to you, it truly does depend. Because RxJava, yes, I know. Thank you, this side of the room. RxJava may be too complex for you and your team or what your company is interested in handling. There are other solutions available. I'm sure you're going to hear more about them even today at this conference. But on the other hand, it's extremely pervasive, and it's everywhere, and it's in tons of languages. So it really, truly does just depend. But hopefully today you understood the basics. We talked about the observable, the observer, and the operators, and how they all work together to make RxJava what it is. So I'm hoping that you feel a little bit closer to getting up that learning curve, and you have a better understanding of how RxJava works under the hood. Thank you so much for attending. I have a link to my slides and various resources that can help people who want to learn more about RxJava on my website at adavis.info. This is my Twitter handle, BrownGirlDev. I tend to tweet very interesting technical things and also random nonsense, so follow if interested. I'll be around for the remainder of the conference, and I would love to talk to as many of you as possible. So once again, thank you very much.